Momentum question. Puck A has some kind of velocity initially. Puck B is just sitting there. We're told after the collision, puck A has a velocity. So they collide. So this is before. After the collision, we're told, well, first of all, the puck A moves along and then boom, collision. And then after the collision, we're told that puck A has a velocity to the left, at least in my question. Final velocity is to the left, some value. And puck B has a velocity to the right. And the question is, what was the initial velocity of the puck here? Actually, the question is speed, so you're always going to answer to positive. First of all, it does not say it's an elastic collision. So you can't assume, you can't use those equations, those kind of fancy equations for elastic collisions here, but you can always use any kind of collision. You can always use the conservation of momentum. Conservation of momentum is means that the change in momentum is zero. It means that the momentum before the collision, which the momentum before the collision is equal to the momentum after the collision. The momentum after the collision we can calculate because I think we know both of the masses. We know the mass of A, we know the mass of B. So we can calculate the momentum after. That would be the momentum of A, that's the final momentum of A, plus the final momentum of B. So instead of saying after and before, I'm just going to say final and initial. And you know, you can calculate these. This is the mass of A times the final velocity of A, plus same thing for B. We can calculate these two individual momentum. Notice if you keep track of signs, where that is positive, that direction is negative, these are carrying momentum in opposite directions, so we expect this to have a positive momentum, this to have a negative momentum. Add them up and see how much momentum this puck initially had, and you can solve for the initial velocity, which is unknown, but because of conservation of momentum, you can match these two momentum, both initially and finally, on either side of the collision. You know they're going to be equal, so you'll be able to calculate the total momentum afterwards, and that's going to equal the total momentum before, which was carried entirely by puck A.